Okay, we're going to return actually back to probability, which is where we started in this unit. But now these probabilities are going to be computed using our different counting methods. So the basic counting principle, permutations, combinations, things like that. So probability, remember, is the number of ways the specific event can occur. So that's going to be like what's described in the problem over the total possible outcomes. So no rules on what has to happen in terms of that denominator. That's kind of like the anything goes. So we're going to pick a 4-digit garage code. What is the probability the last digit is an even number? So this is one that's going to be, again, a basic counting principle. So our numerator is going to specifically deal with the last digit is even. So the first digit can be anything. There are 10 digits. The second digit can be any digit as well. The third digit can be any digit, but we are specifically asked that the last digit is even. There are 5 even digits: 0, 2, 4, 6, and 8. The denominator is just, I need to make a 4-digit garage code. It doesn't matter whether the numbers are even, odd, multiples of 3, or whatever. So for every one of those 4 digits, you have 10 choices. And whenever you multiply that out, and actually it's easiest just to reduce, the 10 over 10s, those all cancel, and 5 over 10 is 1/2. All right, a 4-digit garage code is selected. What's the probability there are no repeated digits? So the numerator, again, no repeats. So the first digit can be anything we want. You've got 10 choices. Once you've pulled out one of those numbers, you're not going to use it again. So you would have 9 choices for the second, then 8 choices, and then 7 choices. And the denominator is, I just need, again, a 4-digit garage code. It doesn't matter whether I've repeated the digits or not. So 10 times 10 times 10 times 10. I'm not going to go through any of the reducing here. This is just a little easier to go ahead and multiply straight across. So 5,040 over 10,000. And again, no need to reduce. Just leave it as is. Okay. In a lottery, we have 50 balls numbered 1 through 50. They are put in a machine and 6 are drawn out at random. If you match all 6 numbers, you win. Yay! And the order in which the numbers are drawn doesn't matter. So what's the probability you win if you bought 3 tickets, each with a different set of numbers? So the numerator is how many chances you have given yourself to win. You have given yourself 3 chances to win because you bought 3 tickets. Now the denominator is how many total possible sets of winning numbers are there, okay? And it very clearly says the order doesn't matter, okay? Order doesn't matter. So there are 50 numbers, and they are choosing 6 of them to be drawn as the winning numbers. And so you have a 3 out of 15,890,700 chances. Not very good. Don't play the lottery, save your money, buy something else. All right, moving on to question D. A bowl of candy has 13 peanut butter cups and 9 Kit Kats. You are picking 2 at random. What is the probability the second is a peanut butter if the first was a Kit Kat? So again, this is like a given that. This is one of our conditional probabilities. We want that the second is a peanut butter cup given that the first one is a Kit Kat, okay? So we know a Kit Kat has been drawn. So again, essentially, there are now 8 Kit Kats in that container with the 13 peanut butter cups. So what is the probability you pull out a peanut butter cup? 13 peanut butter cups out of 21 total pieces of candy. All right, if 5 people are seated in a row of 5 chairs, what's the probability Beth is seated on either end of the row? So the specific thing here, or the thing that's special, is Beth. She has to sit on either end of the row. So let's consider Beth first, okay? How many different choices does Beth have if she has to be on an end? Well, Beth actually has 2 options for where she could sit. She could sit on the far left or on the far right. So Beth has 2 options, okay? Once Beth sits down, now the next person comes up and they're going to sit. They have four choices of how many chairs are left. Then the third person comes up. They have 3 chairs. The fourth person now has 2 chairs that are open to select from. And then the last person is stuck with whatever's left. Okay. As for the denominator is I just need to sit 5 people down in the row. Doesn't matter where they sit. I just need to sit 5 in a row. And so that is going to be the first person has 5 choices. The next person has 4, 3, 2, 1, or 5 factorial if you would prefer to write the denominator that way. Notice real quick that the 4, 3, 2, 1 cancel top and bottom. So that's just a good old 2/5. Again, a fairly easy way to do that one quickly in your head. All right, and then the last one on this page, 5 cards are dealt from a standard deck. What is the probability of being dealt 5 black cards? So again, here, whenever you're looking at this problem, this is one with combinations. The order in which you're dealt the cards doesn't matter. So your numerator is going to be, I need those 5 black cards. Well, there are 26 black cards in a deck. You are being dealt 5. And your denominator is I just need any 5 cards dealt to me. So how many possible 5-card hands are there? There are 52 cards in a deck, and you would be dealt 5. So the probability is 65,780 over 2,598,960.